This is PPL Electric Utilities Power Lab, a lab facility designed and set up to be able to serve the needs of students that are taking classes in electrical power systems 1 and 2, as well as graduate students taking classes in control and operation of electrical power systems. The laboratory is equipped with all kinds of facilities, all kinds of equipment to enable them to try out concepts they've learned in theoretical coursework. So we can emulate systems with solar energy, with wind energy, with conventional electrical power generation systems, transmission lines, all kinds of loading devices for the electrical system. So this will enable students to really have a very practical connection between theoretical work and very practical side of things. The PPL Electric Utilities Power Lab has 3 main buses. Each bus has a conventional generation system. For us, the generator simulating the electrical utilities generator is a motor generator set, which is a combination of induction motor driving a synchronous machine. So that is the generator. We have one of these on each bus. The generator on this bus is connected to the physical bus, 3-phase bus, and these are the switches, the electromagnetic switches controlling the different breakers on the bus. This is an adjustable drive that we use to control or regulate the generator. Also connected to the bus, we have the photovoltaic emulator to help us simulate solar energy activity, and likewise some DC power supply to simulate fuel cell activity. And in addition to that, we have transformers that are connected to the bus from where we tie transmission lines to the other buses. We also have electric loads. These are electric motors to help put some loading on the bus in general. We monitor all the measurements available from each of these individual devices. So we have smart meters where much of the information collected can be displayed and accessed by computer networks. And then we have automation devices that help us interact with each of the devices, whether we want to operate switches or implement some control mechanism. We do have specialized systems that do that. Also, we have equipment to achieve protection of the power system, to protect from overload, to protect from reverse power and variety of other faults and problems that we do not want to reflect or to happen on the power system. In this setup, we utilize as much as possible the same kind of equipment that is found in the power industry. So the goal is to help students learn from real equipment that they might encounter when they go to work in the power industry. So this is a set of 3-phase inverters that are connected to batteries in the battery room. So through these inverters, we're able to take energy from the battery, turn them to AC, and synchronize to the AC grid. In addition to that, we do have a smart load. So the smart load enables us to create different load types that we want to use in testing the system. Other loads available are these are electric motor loads, 3-phase loads that can be used to test the system as well. And on the top here, we have a range of instrumentation panels where we essentially take the raw data from each of these devices and scale them down so that we can have them interface to our instrumentation systems. Variable field drives here are used to control the induction motors, to adjust the frequency and obtain different characteristics for the loads. The north bus section of the PPL microgrid system is right here. The south bus is right here. So the third and the final bus is the west bus, which is located on this side of the road. The west bus is tied to the rest of them through transmission lines that are on these cable trays. And in between these buses, we have the control station, where data from each of the buses are collected, processed, and analytical work or operation and control work is performed through these workstations, and then we can display the results on these monitors. So we're going to go ahead and run the grid, the microgrid system, for you to see how it works. So what we've done now is to show how to start up the microgrid system. We have the generator turned on, we have the buses connected. In this case, we have two buses put together in kind of a radial feed, and with that we turn on different electrical loads. We have a battery storage brought online, and we see how the grid responds to that. Different measurements, current, voltages, powers consumed because of those loads. In a typical power systems course, we can take a look at the network and then see if what we are measuring agrees with what it should be in theory, because we can model the network using software systems and then compare results with the physical measurement we have here. For graduate students, we can go one step further by designing controllers for regulating the grid. In other words, deciding what to do with each of the loads, whether you want to turn off load, whether you want to feed from the battery, whether the time is right based on cost of energy to turn on certain load or turn off certain loads. So in the future, we intend to expand the work to that, so that even from outside of the laboratory, students can work, can interface with the grid and be able to try out their computer algorithms for controlling this. So that is where we want to take this in the future.